So our topic is future of wireless communication. We are very fortunate to have a list of distinguished panelists with us today. So I gave them a quick introduction, then we can get into the topic. First one is Sashi-san. He's with Docomo. He has been doing wireless for a very long time in Docomo, and he's also a veteran in 3GPP. I guess by now you should know what 3GPP is. If not, we should have a conversation. So Satoshi has been serving as the vice chair of Working Group 1, then the chair of Working Group 1, which is a physical layer spec. Then he moved on to the vice chair for the RAN plenary. Now he upgraded himself to 3GPP SA vice chair. Gary is, okay. So you didn't follow the order. Gary is vice president of Samsung, so he's leading the beyond. We don't talk about the 6G somewhat, but I guess he's leading the beyond 5G and 6G wireless research and development, mainly focus on massive MIMO and millimeter wave. Thomas is is principal researchers with Ericsson in the Bay Area. He also have very long tenure in Ericsson, start from 2.5G to 5G, now 6G. He made a lot of contribution to 5Mac, coding, modulation, rate control, the stuff. And also lately he focused on also AI and wireless. We have Professor Heath. Professor Heath has been working on MIMO for wireless communication for 20 plus, 25 plus years. The insight from their research has shared the how to make the MIMO working reliably for the wireless communications. He has been with UT Austin, a faculty member for a very long time. Then he joined North Carolina State University for a couple of years. Finally, he made the right choice and came to San Diego. Now he's with UCSD. Fun fact, I just got to know, Professor Heath is also a licensed amateur radio operator and private pilots. Impressive. So finally, I have my colleague, Tim Fan. Tim Fan started with his career as Bell Lab. Then he joined Qualcomm 2003, make a lot of contribution on the LTE Advanced. Lately has been leading one of our signature 5G 6 project. He in the past couple of years, he's also serving as the technical working chair of NextG Alliance, which is to promote the North American 6G technologies. So welcome and thanks for joining us. All right, so John had a different kind of format. He was going through the panelist. I'm going to go back to the traditional approach, which is I sent a couple of areas to the panelists ahead of time. Very open, because when I look at the future of wireless, such an open-ended topic, so now I don't know where to start. So I sent them a couple areas. I'll try to go through each of the topic with them, get their insights. If I'm being successful to get them disagree with each other, that'll be even greater. So, so the first question I asked them is. Obviously, wireless and especially mobile communication has been such an integrated part of our daily life. Fun fact, I was on vacation recently, and one of my partners lost their phones on the train, and she had been basically borrowing phones for everyone all the time. Then you realize how much you are dependent on your phones. So obviously, over the years, we have learned how to do wireless reliably and effectively. We have a couple of talks already on that. So as we look to the future, what are the open questions and areas that you think we should spend more time and resource as part of the wireless communication? Maybe you can just start with some random order and then we can go from there. So maybe Satoshi, you can start right.
Okay. First of all, thank you very much, Yongbin. And also, I'm Satoshi from Japan, and I'm doing the leading of the 6C and also space communication and AI in Docomo, Japanese operators. And open question is a good time because that's my feeling is currently that in the operator, we are struggling how to get the money or how to create a new business model, even for the 5G. So it means that we have some discussion within the operator about what is 6C. And some operators say that we are struggling what is the meaning of the G, because it's the OFDM or CDMA or no, what is the change of the next generation. Someone say that software only, or someone say that no big change. But on the other hand, operators want a new model. So this is one question. And next question from my side is the population decrease. This is one of the topic headache in Japan. Maybe not only for Japan, but also the China and Korea and Sweden and Italy or some of the countries. We will have a dramatic population decrease. And this is a totally headache of the MNO because, for example, in Japan, in the north area, the rural area, the population decrease will be 30% for upcoming 10 or 20 years. And for MNO, it can be easily calculate our revenue will be 30% decrease because we are doing the subscribe business. So it means that the operator's point of view, it is also headache. And this is not only for the MNO, but also all of the infrastructure company. It means that the electric company or gas company, or even for the car company, or like Toyota or some car, not only for the car, but the road company. So this is kind of the second question I'd like to discuss.
Thank you. Thomas?
Oh, okay. Yeah, like you said, wireless connectivity has become an integral part of people's life in the last 20 years. So looking forward to the future of the evolution for wireless network, we at Ericsson have been thinking about a few overarching and fundamental attributes that would like the mobile network to have in the future. And we can use this as our guiding principle to drive the research directions. So a mobile network is becoming a fundamental part of the society. So trust in the connectivity and trust in the data delivered by the connectivity and trust in the compute capabilities and platform to support new AI applications or the augmented reality applications will become ever more important. So we have been looking into technologies to enhance network availability, reliability, and resilience under various operating conditions. And introducing AI, it will be possible to enhance network performance and to simplify and optimize network management. But this data-driven improvement is made possible by observing and in some cases collecting a large amount of data. So it's very important for the network to use this data responsibly and to protect the user's privacy and to ensure the security of the data during its lifetime. And of the AI technology itself, we also need to ensure the robustness of the AI models. And we need efficient ways to monitor the model performance in deployment. And in some cases, we also need to be able to adapt the AI models if the operating conditions can deviate substantially from the training data. And a third attribute that will be important is the sustainability. So before the 5G NR, Ericsson did a study in 3GPP on the design of an energy-efficient mobile network by minimizing the always-on transmission, such as the common reference symbols in 4G LTE. These concepts formed the basis of the 5G air interface design. And our research indicates we can take this idea further to ensure that 6G is even more energy efficient. And furthermore, we think the 6G network should support low-power wide area IoT connectivity from day one. This will enable industries and society to collect intelligence on the physical world and to use their knowledge to achieve more efficient and sustainable use of resources. So in summary, dependability, trusted compute platform, sustainability are among the important attributes we would like the future of the network to evolve to.
Thank you. Thank you, Thomas. I think that's very important. We will get into a little bit more discuss about AI and wireless in next. Maybe Gary can share with us your thought about this.
Yeah, so my view on this is I think from 4G to 5G, the industry has been pushing for higher KPI like data rate and latency reduction. But I think to make the next generation transition, we believe we need to care about other attributes such as the sustainability and the user experience. So we look at this next generation from this new mindset, and we want to look at the attributes, for example, the using AI as a new tools to improve the performance of the radio network from the modem to the control layers. And also we can use AI to design the waveform, for example, to achieve better kind of performance and efficiency. And the other aspect we are looking at is sustainability, basically improve the energy efficiency of both the base station side and the terminal side. So we're looking at the new kind of semiconductor technology that actually can improve the PA efficiency, new architecture that actually can improve the RF performance and the network efficiency of using the scheduler, for example. And the third aspect we're looking at is the coverage. I think one main issue for 5G right now is actually the coverage issue, not just the millimeter wave band and but also for the mid band. So adding more base stations to our operator customers seems to be very challenging. But the existing kind of this design actually has limited coverage, mainly due to the channel propagation characteristics. So how to improve the coverage using the new technology is something we're looking at. For example, using the distributed MIMO technology and other technologies for millimeter wave bands, such as joint phase and time array. So we'll talk about that later if you're interested in this. And those are the new attributes we are looking at, and we hope we can build the next generation network with better sustainability and better user experience. Thanks.
Thanks, Gary. So the Professor Hiss is, I guess, only faculty members in the academic world in this panel. So we'd like to hear from your perspective in the research areas. What are the open areas you and your group are focusing on?
It's an interesting question. So you're asking me to give away all the good ideas before we have a chance to work on them. Yeah. So I guess first of all, I'm glad that we have a panel without slides. I was though hoping just that we would all make little presentations and there'd be no time for discussion or questions. So I'm a little disappointed about that. I think that while I appreciate the comments, I really have to disagree with what everyone has said so far, because no one has mentioned MIMO, multiple antennas. I mean, this is the key technology for 6G. Coincidentally, it's also the technology I'm working in.
I think in our world, the MIMO becomes such a default. Is given.
Yeah. But I think that we have seen that the support for MIMO has been implemented in the standard and not necessarily realized for various reasons. Multi-user MIMO is still a classic example of a technology that's still not working as well as it could. So I think that a lot of work is needed to develop these fundamentals out, whether it's in the beam management, the feedback, but generally speaking, supporting larger arrays, more antennas, smaller antennas, going to upper mid band, increasing the reconfigurability of the hardware and the interfaces between the signal processing and the hardware, I think is very exciting. And it's something that the standardization process pushes compartmentalization, but I think it might be time to revisit those areas. I mean, you never really discuss the antennas used for MIMO in the standard at all, but that's something that's very, very important. And I think when you have a phone with supporting 70 different frequencies, you need that tighter integration. So I think that's one area that's definitely interesting. Different than MIMO, but related. It's another technology. I think this integrated sensing and communications is very important. It's a different way of leveraging the electromagnetic spectrum, and it empowers a lot of these other applications that may bring revenue in cellular systems. So I think that's another very exciting area. And I could go on, but let's keep going.
Yeah, those are great insights. I think we definitely jam a lot of antennas in the smartphone devices. I think Kamal probably have a session later on talking about RF. How to kind of put that also upfront as part of the system design definitely is going to be interesting. Tim Fan, anything?
Yeah, I think I want to talk about the GigaMIMO, but this guy stole my thunder. But that's just one solution, right? So I think a much bigger question. I think Satoshi hinted on earlier, right? There are many challenges. New challenges we're going to face in 6G. For Japan and Korea, I think it's a population decrease. How do you deal with that? So in my mind, the overall theme for 6G that we're trying to do is how do you achieve highest efficiency while dealing with the exponential growth that Rob talked about, the 26% a year. That's 1 dB, right? So we all know in our mind we are communication engineers. So 10 year, 10 dB, 10 times. So how do you deal with this, tenfold increase in every decade without breaking the bank, right? So highest efficiency is what we need to achieve, and there are many aspects of it. There's so many details, right? MIMO is one of them. Bands, spectrum, right? Misha talked about this is really, really important to actually have the spectrum. Otherwise, we know that the cheapest way to grow spectrum is through spectrum. Grow capacity is through spectrum. And then you go to MIMO, then you go to other fancier mechanism. All those are more complicated, more expensive, more energy intensive. Yeah.
I mean, MIMO is more expensive than acquiring a bunch of new spectrum.
Wow. There's spectrum costs.
See, I like this.
Yeah. For energy cost, I'll bet CA versus MIMO any day. To get that data rate, right? So that's it.
Fair enough.
So efficiency, really we need to go after this efficiency, right? People also talk about the sustainability, battery, all those things. Can you do it without battery? Right? Again, right? That's the ambient IoT. That's a batteryless technology that gives it highest efficiency. So I think open problem is how do you have the high efficiency G, right? Should be something that's different from all previous Gs. I think Obama once said about global warming, right? He said, this is the first generation will feel the impact of global warming. And this is the last generation you can do a damn thing about it, right? So that's specifically about sustainability. But I think this efficiency problem, that's how important it is. It's not only on global warming, but for wireless communications for the next decade. I think it's probably the most important problem we need to solve.
Yeah, definitely. I think the power consumption of wireless network, it is, I think, Rob, you mentioned you guys spend a lot of money on the electrical bills. I think that also echoed by many other operators. I'm sure Docomo felt that too. Especially for some of the new base stations where you have a massive MIMO, then the power can either go to hundreds or thousands of watts and was running all the time. So how to have a very efficient radio, power efficient, that's actually definitely important. Sorry.
Actually, I just wanted to jump in because I had a question earlier, just in the spirit of having a discussion here. So two people mentioned this population decrease. So I just want to understand. So an application of 6G is to help people make the population grow, or is to help cope with the decreasing population? I'm sort of confused.
For example, I think that's easily way is let's utilize AI or automation as much as possible. But AI itself is, I think that's the AI is anyway the totally buzzword for mobile. All of the MWC, you can see that all of the booths we say that AI. But on the other hand, business model or some of the business point of view, we really want to have a concrete idea to take care of it. And as Yonbin said, and also Tim Fan said, power consumption and also data calculation, but also sharing or many aspects we need to combine together. So that is one of the aspects I'd like to have a concrete discussion.
Yeah, definitely. I think the population reduction is a trend for a lot of regions. But also, I guess behind that, also the aging population. So I think there, what we do actually can be a beneficial factor to help people live a, happy life, even with more aged populations.
Yeah, so I agree with that. I think one potential use case is robotics, right? So for this, the senior care and the service, so this potentially using AI and communication kind of technology together, the robots can take care of a lot of the mundane type of service type of work. So the interesting part is the human only has 2 eyes, right? So you only can consume certain amount of data, but the machines like robots actually can consume unlimited amount of data, and it can generate a lot of data by sensing. So that indeed could be the driving kind of use case down the road, given this kind of aging population and the population decreasing case.
Yeah, they agree with our prediction for the IoT use cases. So in the past, the IoT deployment was maybe not so successful because you can collect all the information, but you don't have a good way to really parse and understand to gain the intelligence to take the next step. And now with the need to increase productivity because of population shrinking, the IoT to collect the physical world information and then use AI to form intelligence and take the steps to increase output per labor. That will be
Yeah.
I think that's, as I said, within, for example, in Docomo, we are doing the internal discussion without using the terminology of the AI. But if I will use the AI terminology, there are multiple definitions. One can say that's the AI for the network. It means that in the mobile network, we will utilize the data or AI as much as possible. This is one approach. Another approach is a network for AI and also AI for network. So it means that my definition is for the future generation, as you said, that all of the network should be optimized not only for the human beings, but also AI or robotics or car or something. This is a machine type. So it means that in the past decade, operators only focus on the human beings. It means that the smartphone is also human beings, AI or DR. And also Tokyo or Paris, we are concentrating the many base stations. But for the future, if we focus on the nature or robotics, how to get the income from these kind of robotics or AI is also one of the headaches. So there is no human beings, but coverage, and how to get the business model from this kind of area. This is also, one can say that the drone delivery or auto driving or something like that. But anyway, human beings will consume money for this kind of area. So this kind of discussion we are now discussing in Japan.
Very good. So we have 10 minutes. Do we have 10 minutes? Okay.
15 minutes, 43 seconds.
No, that's okay. So I want to move on to so we talk about open, issues and problem people can work on. What do we try to get to? So next one, I want to get your input about, in your mind, what would be the big challenges that we'll be facing as an industry moving forward. Obviously, we have technical challenges, maybe the other challenges. One aspect, maybe I can start with education. So this may be true or not true. In my years in graduate school many years ago, we have a big population of people working on wireless and communications. As we kind of to a later stage, that seems to be some changes. Maybe Professor Hisse, you can talk about your thought about where educations are. What are the challenges we may be facing for wireless communications?
Yeah, I think that's a good question. One of the challenges is we see a shift of interest for students to go into more AI-driven fields, so they can work at certain companies that are just split their stock by 10, for example. So, I think that's definitely going to be a concern for you all. Now, whether you think that the students need to know the fundamentals, I think is the key question, right? Like, I believe that, and I think that UCSD is great for this, is in the fundamentals, communication theory, information theory, not forgetting about models. Model-based thinking is incredibly important for building intuition, for making decisions. We don't leave everything up to the machine. And what I see is that, aside from a few isolated schools like here, you're really going to see vastly fewer engineers trained that have that thinking. And I would be concerned. And the easy solution to this, in part, would just be to pump in a whole bunch of more money here, because we've already got the program. We're all welcome. Several faculty here with open arms, open hands. But I think that's something that you all need to think very carefully about, because if the students start to get pushed back that, oh, you don't know anything about communications, but AI, we're going to hire you. I mean, if they start getting that feedback that, yeah, they still need to know something about fundamentals, would be very important. The other thing is, it would be incredibly useful if you as an industry, when you're working with these, especially with NSF, would reemphasize the role of fundamentals. We've seen a ton of money coming into more experimental activities with this idea of, oh, we're going to do wireless, we're going to build a prototype, generate a bunch of data, and all these professors and their students are going to take that data and write a bunch of papers. And unfortunately, most of the things that many of us want to do cannot be prototyped, which is why we're trying to explore interesting new directions. If it can already be prototyped, a lot of the things, like, I don't want to do it. And so it would be great, instead of putting $100 million into like 4 experimental prototypes, we had 300 single PI grants funded in communications. I mean, that would have generated, I think, so much more intellectual development. Maybe I shouldn't be quoted on that, but I do think that supporting fundamentals in these areas will help, because if there's money, we'll be able to recruit, and we'll be able to pull some of the students interested in AI, shift them over a little bit into the fundamentals. I'll stop there.
All right.
But I'll give you my Venmo information afterwards. Anybody? I mean, sorry, the university's Venmo information.
I think John's in the audience, so any others you want to share?
So education in wireless communication fundamentals is super important. We have found that it's much easier to train someone with a good wireless background on AI than the other way around. So in the AI community, they have this concept called induction bias, which means you choose a specific neural network components or architecture, because these choices, they agree with the desired properties or processing you would like to do based on your domain knowledge. So in our wireless use cases, let's say we have received signals from 64 antenna ports, and we want to use convolutional neural net. And then how do we organize the received signal data? Do we, for example, take the antenna dimension and the time dimension as a 2D data, and then we use a 2D convolutional layers as if we are doing computer vision? Does that agree with the basic principle of MIMO processing? Can we get better performance complexity trade-off by organizing the data in a different way and use a different type of convolutional layers? To analyze and answer these questions will require solid background in wireless. So a strong academic wireless program such the one as UCSD is really appreciated by the industry.
Yeah, the other thing I want to add is the research, right? So from this global competition perspective, I think the advantage in the US is the university research. The ideas generated by the faculties and students can indeed drastically change the technology roadmap. So this has happened in the past several decades, right? So we hope this can continue, right? So basically creating new ideas from the universities and train the students to fill this pipeline. So we, as the industry players, we can continuously have the fresh people coming into our workforce with great ideas.
Anybody else want to share? No? Okay. In this panel, I like to leave some time for the audience. So if you have any question for the panelists, you can prepare. So you can go to one of the microphones, can ask the panelists about your questions. While you're preparing for that, I think I have another question to the panelists, which is this summit is about wireless plus AI. At least in Qualcomm, we sometimes we run into this kind of paradox, which is many of us trained by classical theories of wireless communications, and then you have the new thinking about AI, which is you get a lot of data, you put a good model, and you do a lot of training, and you get a good design. So there's always this kind of you would say somewhat contradict kind of thinking and frameworks. I don't know if any of you can share some thoughts about how do we kind of make the best out of those two worlds to me.
I usually think we start with what we know and to attack the problem where we do not know enough. So let's take the positioning or sensing problem as example. One of the important steps is to determine where a wireless link between the transmitter and the receiver is a line of sight link or is a non-line of sight link composed only of a refraction. And we have found that using simple model trained with data, it can achieve a higher line of sight classification than the combination of conventional signal processing heuristic. And this is where AI or data-driven approach can help when we don't have a good physical model on the problems we would like to solve. On the other hand, in this positional sensing problem, the propagation delay estimation, that we can do it very well using conventional signal processing. The AI model does not really add value. So this is one example that we can see that we can combine both conventional signal processing and this new data-driven AI approach, taking their respective strengths and to avoid weakness, to combine to have a good solution.
Those are very good point. Yeah.
I think on the AI side, wireless AI side, I think in the last panel, I think Carl touched upon this. It's about actually interoperability for the AI models, right? If you are doing something by yourself, you're just using AI to replace one of the signals processing blocks. I think it's somewhat straightforward, right? You can make the judgment call saying, hey, I'm half dB away from the bound. Who cares? I'm going to, I know there's not much to be squeezed out, and that's fine. But the biggest challenge I'm seeing for wireless AI is this interaction, the two-sided models, we call it. Essentially, you have the network side and you have the terminal side. When they have to work together, how do you actually make it scalable, right? A Qualcomm chipset need to work with Ericsson, Nokia, Samsung, and even different models, different deployments. They're all very different. So how the hell do you actually make it scalable, right? So we typically in 3GPP, we pride ourselves, say, hey, everyone's saying cellular is better than Wi-Fi because we have performance testing. We know exactly what performance you're going to get, right? That whole framework is gone because AI is data-driven, which means whatever you're doing is actually quickly adapting to the network. The spec, the area interface is adapting, to the particular, local scenarios. So that's where AI give you a gain, right? If it's targeting the median, classical solution will be plenty good. So really, it's where you have local adaptation that will give you the gain, but then that destroy the, interoperability and the testing condition. Everything is changed from the field, compared to the testing condition. So I think the biggest challenge in my mind for wireless AI is to solve the adaptability issue. In 3GPP, there are some terminology, people call it life cycle management, and the performance monitoring. How do you monitor the model drift? And so those are the probably biggest issues we need to solve if we want to get the full potential of AI, take advantage of this data-driven approach.
Yeah, that's a good point. I think as we get into more and more like inter-vendor kind of situations, we're definitely facing more challenges. The traditional way of doing IoDT will need to be upgraded to deal with these kind of new situations. We have a couple minutes. Any question from audience? Yeah, please.
I will try to speak a lot. And my name is Panelist from General Motors. I think to follow Ping Pong and Robert and Thomas' point, and we can use large data to train AI model for various channel, various moderation, adaptation. We can do all of that. But the question is, your model will base on what is the data you collected. And we all know particular for the automotive or communication engineer like me. And we have a lot of very strange channel combination, and those are the rare situations. How we handle those counterfactual situations using existing AI, big data driven.
Maybe I can give a first take on it. It's actually very interesting. We also thought this. There are so many specific scenarios where, AI might break, but turns out, most of the models are quite robust. Actually, the more data it ingests, the more robust it gets. And these specific corner case, when you have failure situations, in wireless communications, it's not that bad. I think it's not life and death. You lose a packet, you don't, cause a car crash. So far, it hasn't been the bottleneck we're seeing. The bottleneck we're seeing is we don't have enough data. That's we just don't have enough data for training. So I think this come back to some of the, I think folks are talking about is where do we get the data? Is the operator going to give us the data, or the infra vendors or OEMs? On chipset we do observe some data, but there's no user consent. We cannot even use that data. Right. So I think as long as we have enough data, I think for communication problems is relatively robust. The corner cases so far hasn't been creating a lot of headache for us.
So another important aspect is this so-called on the site training, right? So if, as Ting Fang said, if we can get sufficient data, we can train the model at the base station side. Actually, on the fly, that's actually possible. But the current base station is not designed this way, and also there's no kind of a interface protocol from the radio unit to the data unit, so that we can actually move the data back and forth from the radio unit to the computing engine. So I think a lot of things need to be standardized later on, and but I think again the important thing is to get the data and also get the data from the field. I think that's going to be a huge effort, and there could be a lot of innovation that's related to this kind of data collection part.
I think that's for example, Docomo are doing the many data on the AI business. But on the other hand, my feeling is operator data is not enough. So it means that what is a meaningful data, and it highly depends on the use case and the business model. But generally speaking, my feeling of the current mobile industry AI is a totally proprietary situation. It means that, for example, all companies do not want to open the AI data and the algorithm to other companies. So, for example, operators sometimes say that operators don't want to have a vendor lock-in. But my estimation is in the future, in the near future, maybe AI lock-in will be coming. So this kind of situation is one of the struggling and proprietary situation in my estimation. But on the other hand, we want to have a collaboration, at least from the operator's perspective. So this kind of collaboration, and also we'd like to have some of the who will be the winner, and by using this kind of collaboration and also standardization and also business model. So this kind of discussion is very important.
Very good. I think we have a fully agreement. We need more data, more different sources of data. I think definitely that's something, for our industry. We need to start thinking about that so that we can make the full utilization of all the potential of machine learnings. So with that, I think we're done, right?
More time.
Right. So with that, we are wrapping up this, session. I want to thank all the panelists for spending time and share your insights. Thank you.